Alright guys, we're going to talk about the chain rule for derivatives now. This is something we use when we have something called a composite that we're dealing with, and so that means it has kind of an inside and then an outside area, and we have to take the derivative of both. So let me break down the steps to do this. So when we say you have like a composite equation or function, that means it's in the form of you have like an outside function and an inside function, right? So outside would be f and inside would be g of x. And so the way that we take the derivative for these things is we take the derivative of the outside and then multiply it by the derivative of the inside. So the way we denote that is we say if we take the derivative of y, then first we need to take the derivative of the f of x, right? In this case, f of g of x. And this is just with respect to the outside portion. We'll break down what that means a little bit more. And then we multiply it by the derivative of the inside function, g of x. Another way that you can think about this is that we take the derivative of the outside and multiply it by the derivative of the inside. So I think the best way to understand this is just by doing some problems and breaking it down as we go. So say we have f of x equals x squared plus 7 to the third power. Take a minute and try to think what would be the outside function and what would be the inside function. Well, if you think about it, we have something to the third power, right? Something to the third power. We could call this, if we wanted to, we could say u to the third power, where u equals x squared plus 7, right? So if it makes sense to you to kind of substitute, you can think about it like that. So our outside function is going to be this u to the third power, x squared plus 7 to the third power. And then, let's change colors. If we think about what's our inside function, well, that's whatever u is equal to, right? So it would just be this u equals x squared plus 7 part. Just the x squared plus 7 part, that is our inside. So let's break it down. So that's just this area on the inside, x squared plus 7. So let's find the derivative of this by applying our rules. So remember we said we need to take the derivative of the outside function first. What's the outside function? That's whatever to the third power, right? U to the third power. If we think about our power rule, all we need to do is bring the 3 out front and subtract 1, right? So 3 out front, now we have 3 times x squared plus 7, because we're leaving the inside alone, right? 3 minus 1, that's to the second power now. And then we multiply by the derivative of the inside, x squared plus 7. X squared plus 7, well, again, we have a power rule, right? So we need to bring the 2 out front, subtract 1. And then what's the derivative of a constant? That's just 0, right? And so we'd be multiplying by the derivative of x squared plus 7, which is just 2x, right? 2, bring the 2 out front, 2 minus 1 is 1, so it's just 2x. So let's go ahead and simplify this out a bit. Let's combine our 3 and our 2x. That would be 6x times x squared plus 7 to the second power. And now let's FOIL this out so that we can expand it a bit, right? So we'll leave 6x to the side for now, but we want to FOIL out x squared plus 7. If you don't remember how to FOIL, you break this into 2 parentheses, and then you go first, outside, inside, and last, right? So what this would be is x to the 4th plus 14x plus 49. And again, if you don't, or x squared here, and if you don't remember how to do this, no worries. You can go check out some algebra videos. Calculus is hard because you're combining all these different math topics that you might not have done in a while. So no shame if you need a refresh on some of the algebra. in order to get through calculus. And then once we've done this, we can go ahead and distribute out our 6x, right? So we would have 6x to the 5th plus 84x cubed plus 294x. And that would be our derivative. So let's go ahead and do an on your own where you guys can try this out for yourself. So go ahead and try to take the derivative of f of x equals 2 times x minus 4 to the second power. Pause the video, try it out, and then we'll do it together. Okay, hopefully you guys were able to give that a shot. Let's go ahead and break it down. So we have a 2 on the outside here, right? That's a little bit different than the other one we just did, but don't worry, that's just a coefficient, so we'll just multiply it in as we go. But let's think about what would be our outside. Well, we have something to the second power, right? And so this x squared minus 4 to the second power, something to the second power is our outside function, right? And so we have something, we'll call it u to the second power. And in this case, our u equals x minus 4. What about our inside? Well, that would be whatever is being brought to the second power, right? That would be our x minus 4 area. So let's go ahead and break down our derivative. Remember, when we're taking derivatives and we have a coefficient, we can just leave that off to the side and we'll multiply it by whatever we take, right? So we'll start with the derivative of the outside. So something to the second power. Remember, our power rule states that we would bring that 2 out front and subtract 1. So we would have 2 times x minus 4. Remember, we leave the inside alone for this first part, right? And now we need to take the derivative of the inside, x minus 4. Remember, we talked about this a little bit in another video where if we have something to the first power and we apply the power rule, that means we're bringing a 1 out front, minus 1 is now to the 0th power, right? Let's do green to kind of go with our inside colors. Now it's to the 0th power, and anything to the 0th power is just 1. And so we would just be multiplying by 1. The minus 4 derivative of a constant is just 0, right? So we don't need to do anything with that. So we would just have 2 times 2 times x minus 4 times 1. And then we could go ahead and simplify. So we would have 4 times x minus 4. We don't need to put the times 1 anymore. And then if we distribute that out, we would have 4x minus 16. And that would be our final answer. And don't forget our little derivative signs there. All right, go ahead and continue practicing this, and I hope this helps.